All right, number 12, we're going to do change of variables to evaluate the integral. We are integrating from 0 to 3, 9 e to the 3x power. We're going to let u equal the exponent expression, so u equal 3x. In doing so, du, derivative of u, would be equal to 3 dx. Don't have a 3, so we would divide by 3. So that 9 will get divided by 3 when I move it on the outside. We would also need to change our limits if we wanted to. We could also just go back, and when we plug it in, it'll work out. However, let's just go ahead and change them. So if we do u equal 3 times 0 versus u equal 3 times 3. 3 times 0 still gives us a limit of 0. 3 times 3 gives us a limit of 9. So putting this together, I'm going to pull the 9 out. Because of the multiple of 3 that I don't have, I can divide by 3. And therefore, I will get this 3 over here. Integral, my limits will be 0 to 9 now. And this will be e to the u du. Integral of e to the u is still e to the u. 9 divided by 3 is 3, so we are getting 3 times e u plus c, evaluated from 0 to 9. And then the plus c will zero out whenever I plug in my upper and lower limit. And so plugging in 9, we'll have the 3 on the outside, and then we'll have e to the 9th power minus, we'll have an e to the 0 power, which will just be 1, and then we'll distribute, so we'll get 3 e to the 9th minus 3, because this is 3 times 1. Or we can just say 3 times e to the 9th minus 1. Either way, it'll be fine. Let's factor out the 3. Same thing here. Not sure either one is less writing. Alright, number 13 looks like our last one. We're going to integrate from 0 to pi over 4 of 3 tan x secant squared x dx. Now, again, the trick here is going to be picking the right term for u. Derivative of one of these is equal to the other, so is tan equals secant squared x, or vice versa? Let's look at our, we want to go to our derivatives, and then that'll help us to figure out which one we should start with. So let's go to, I'm going to go to the differentiation sheet. And it could be a rewriting of this of cosine as well, but I don't think that's going to be it. So derivative of tan is equal to secant squared x. So in this case, I want to let u equals tan, so that when I take the derivative of u, it gets rid of that secant squared for me. Okay. All right, so that's one of the things you want to kind of be thinking about. Not always do we use the one with the power. So u will equal tan x this time. Du is equal to secant squared x dx, and so therefore that would go away. I can pull the 3 out front. Instead of changing my limits whenever I change u, I'm just going to go back and then plug in what we originally started with. So I won't change the limits this time, just to show a different iteration. So we're going to do 3 integral from 0 to pi over 4. So that means before I plug it in, I need to go back and replace u. This is going to be u du. Okay, so du, 3 out, u is equal here. Alright, so now when we do power rule, if I raise this to the power plus 1, so they give me u squared divided by 2. So this will be the 3 on the outside, u squared divided by 2 plus c. And this is going to be evaluated from 0 to the power of 4. In order to do that, I need to go back and replace the u with what I started with. So instead of changing the limits, I just go back and plug it in. So 3, this is going to be tan of x squared over 2, evaluated from, now the plus c, I'm not writing it because it's going to go away, evaluated from 0 to the power of 4. Alright, so we have 3 tan pi over 4 divided by 2 minus the lower limit of tan, now this is squared, sorry, don't forget that. This is tan squared, so tan pi over 4 squared. Doesn't really look like a 4. Tan of 0 quantity squared divided by 2. And I'm going to multiply that by 3 at the end. Power 4, okay, our unit circle. This point right here, both square root of 2 over 2, because tangent comes from sine over cosine. Both of those are the same, so we get 1. And when you square 1, you just get 1. So this is 1/2. So I have 1/2. And then tangent of 0 is here. For the pair is 1, 0. Sine in this case is 0 over 1, which just gives me 0. So 0 squared is 0, divided by 2 is still 0. So we just end up with 1/2 times 3, which is just 3/2.